In today's video, we are going to explore the allotropes of carbon, particularly focusing on graphene and fullerenes. Most of our time will be spent learning about the many ways these fascinating forms of carbon can be used in science and technology. To start, let us quickly remind ourselves what allotropes are. Allotropes are simply different structural forms of the same element that exist in the same physical state. In this case, we are talking about different forms of solid carbon. In a previous lesson, we looked at the allotropes diamond and graphite. You may recall that graphite is made up of many layers, and each individual layer within graphite is what we refer to as graphene. These layers have a repeating pattern of hexagons, where each carbon atom is bonded to 3 others, forming a very strong structure. Additionally, each carbon atom in graphene donates 1 electron to a shared pool of delocalized electrons, which means that graphene is capable of conducting electricity. This unique combination of strength and conductivity makes graphene highly useful in the manufacturing of electronic devices. Graphene is a naturally occurring material and can be obtained from the earth in the form of graphite. However, scientists have also been developing innovative ways to transform these strong, thin sheets into new shapes and applications. One method is to roll them into cylindrical shapes, forming what are known as nanotubes. In addition, scientists have discovered ways to modify the hexagonal pattern by inserting pentagons or heptagons, causing the flat sheet to curve and form a closed spherical shape. These new curved carbon structures are collectively referred to as fullerenes. These include both the tiny spheres and the tubes, and they have a wide range of potential uses. For instance, scientists can design fullerene spheres to enclose other molecules, such as medicine. This ability to act as a molecular cage means that fullerenes can deliver drugs directly to specific areas of the body, increasing the effectiveness of treatment and reducing side effects. Another major application of fullerenes lies in their surface area. Because fullerenes are so incredibly small, they have a very high surface area relative to their volume. This makes them ideal for use as industrial catalysts, which are substances that speed up the rate of chemical reactions without being consumed in the process. The tube-shaped fullerenes, known as carbon nanotubes, are particularly impressive. Due to their tiny size, they are highly suitable for use in nanotechnology and advanced electronics, especially because they can conduct electricity efficiently. Beyond electronics, carbon nanotubes are also used to strengthen materials. For example, the frames of tennis rackets can be reinforced using these nanotubes. This is made possible because nanotubes have an extremely high length-to-diameter ratio, which simply means they are very long and very thin. This quality enables them to add significant strength to an object without adding much weight, which is especially important in sports equipment, aerospace materials, and protective gear. The first type of fullerene ever created was a spherical molecule called Buckminster fullerene, also known as C60. It is a hollow sphere made up of 60 carbon atoms arranged in a pattern similar to a soccer ball, combining both hexagons and pentagons. This molecule is named after the architect Buckminster Fuller because of its resemblance to his geodesic dome designs. The use of these tiny materials in practical applications is part of a broader field known as nanotechnology. Nanotechnology refers to any technology that manipulates structures on the scale of nanometers, which is 1/billionth of a meter. It is now being applied in a wide range of industries, including medicine, where it is used for targeted drug delivery and diagnostic devices, energy storage and batteries, as well as in the development of improved food packaging, cosmetics, and even fashion textiles that are more durable or responsive to environmental conditions. The key message to remember from this video is that fullerenes are not just another form of carbon, but rather, they are incredibly versatile materials that can be engineered and tailored for a variety of high-performance uses. Their unique properties, such as strength, conductivity, high surface area, and molecular stability, make them a vital component of emerging technologies. Whether it is through helping to build lighter and stronger materials or advancing the frontiers of medicine and electronics, these carbon structures are shaping the future of science and engineering.